let me give a very simple example of all the concepts we have just seen. And this is the example that I have been using repeatedly. So let's consider the transformation which projects all of the vectors into the x-axis. Okay, and I have the actual matrix here is 1, 0, 0, 0. So any vector v, for example 2, 2, ends up as 2, 0, which is this one here. So any vector is just projected into the x-axis. Yeah. So basically you just get the x component. So this is the transformation that we are considering, given by this matrix. So the question asks, state the range, null space, rank, and nullity. So let's do it. First of all, what is the range of A? So the range of A is given by the span of the columns. Which is equal to the span of these two vectors, which are the two columns of A. 1, 0 is the first column, and 0, 0, which is the second column. Now, what is the span of 1, 0 and 0, 0? So obviously, the vector 0, 0 is not contributing anything to the span. So we could say that this is equal to the span of 1, 0. And what's the span of 1, 0? This is the x-axis. Yeah? So that is the range of the transformation. And indeed we know that this transformation is squashing all of the input space into the range, which is the x-axis, because it is projecting everything into the x-axis. Next, what is the rank of A? So the rank of A is simply the number of dimensions of the range. How many dimensions? Well, a way to know the number of dimensions is to know how many vectors, how many linearly independent vectors span the space. Since we have only one vector, this is a one-dimensional span. Indeed, the x-axis is a line which has one dimension. So the rank is equal to 1. Next, the null space. So remember, the null space of A equals the solutions for x on the equation A times x equals 0. So let's solve this equation. So A times x equals 0 can be written explicitly like this. So vector x, let's write it as xy. Okay, it's just the two coordinates of vector x, and this is equal to 0, 0. So this is nothing more and nothing less than a system of two equations with two unknowns. And the two equations are x equals 0 and 0 equals 0. Those are the two equations. And the two unknowns were x and y. So can we solve this? Well, of course, it's already solved. So the second equation doesn't mean anything. It's not giving us no information. So we know that x equals 0 is the solution. And what about y, which was one of the two unknowns? Y can have any value. Any value. So let's call it lambda. And this is a free parameter. Okay? So can we write vector x, which is equal to xy? Can we substitute the solution here? So we can say that x equals 0 and y equals lambda. So we could write it like this. Or we could take lambda outside and say that this is lambda times the vector 0, 1. Yeah? So this is the equation of a line, which has 1 degree of freedom. It has one dimension. We could also say that this is equal to the span of this vector 0, 1. Right? Because it's a linear combination of a single vector. And it is a line. And this line is the y-axis. So the null space of A is this line, the y-axis. What is the nullity of A? It is equal to the dimension of the null space of A. So what is the dimension of this line? Well, it's written as the span of one single vector, therefore it's one-dimensional. So the nullity is 1. Now let's check the theorem of dimensions. So the theorem of dimensions says that rank equals n minus nullity, where n was the number of dimensions of the input space, which is 2 dimensions. The nullity was 1, and indeed the rank is 1. So the theorem is fulfilled. So this was a very, very easy example. Let's draw the different spaces. So the input space is x and y. Now the range is the x-axis, yeah? So the range is here. This is the range. While the null space is the y-axis. So the null space is this infinite line here. This is the null space. And here you can now, if you recall what the range and null space means, everything makes perfect sense. So all of the vectors in two-dimensional space end up in the range when we project them. And all of the vectors inside of the null space, which is this y-axis, end up in 0. So any vector that starts up in the y-axis, yeah, ends up as vector 0. So all of these vectors are projected to 0. So that is the null space. Okay? So this was a very simple example of these concepts. So thank you very much for watching.